Hello my dear students, how are you today? Today we'll continue the second unit in this term, Unit 2, Lesson 1, Energy Resources and Forms, Part 1. What is meant by energy? Energy is the ability to do work or make a change. The energy it's the reasons that makes us move, that makes us be able to do work or make changes or do any of our activities. Also, the fuel inside the car engine when it burns and give the energy to move the car. Also, our food gives us the energy needed to do our activity. When the food inside the cell burn, it produces energy. This energy we use it to do all the activities. So the fuel inside the car and the food inside our bodies are similar. Why? Because both of them burn and produce the energy needed to do work. So what is meant by work? Work is the force that act on the body and move it for a distance in a certain direction. So, or again, the force it acts on the body and moves it for a distance in a certain direction. When the force acts on the body to move for a distance, the movement here from one place to another is called displacement. It's called what? Displacement. This caused by the force. From this we can conclude that when the displacement increase, the work done increase. While if there is no displacement, the work done here equal 0. Why the work done equals 0? Because there is no displacement. When a person affected on a wall by a force, the wall will not move, or there is no work here. Why? Because the displacement equal 0. We can calculate the work done by this relation. Work equal force multiplied displacement, the work represented by the symbol W, the force F, the displacement D. The work measured by the joule, the force measured by the Newton, the displacement measured by meter. So if you have the displacement in the centimeter or kilometer, we should convert it into meter. As the first example here, if a car moved for a certain distance equal 20 meters pulling a piece of wood by a force of 75 Newton, calculate the work done by this car. From the rule, work equal force multiplied displacement. The force here equals 75, the displacement here equal 20, so 75 multiplied 20 equal 1500 joule. Don't ever forget writing the unit. In the second example here, a car moved for a distance of 30 meters pulling a piece of wood by a force equal 20 Newton. Calculate the work done by this car. Think to answer it by yourself. Okay, that's correct. If you guess it, answer here equals 600, so that's correct. Where do we get the energy? We get the energy from many resources such as the sun, and it's a permanent source of energy, the wind, the fuel, the movement of water such as the waterfall, and the food, and the nuclear reaction. These are the sources of energy. The development countries try to use the solar energy comes from the sun to produce electricity. Why? Because this kind of energy is cheap resources and don't pollute the environment. It's clean and cheap sources of energy. So the development countries try to use the energy comes from the sun, the wind, and the movement of the water and the waterfall to produce energy more than before, because they are cheap resources of energy and don't pollute the environment. Energy forms and energy and their resources. The energy form here, the mechanical energy, and as we learned it before, that the mechanical energy is the summation of potential and kinetic energy, and it produced from the water motion and the stretched spring. The light energy comes from the sun and electric lamps. The sound energy produced from the radio and TV. Electric energy comes from the wind electric generator and the solar cell. Heat energy produced from the sun and heaters. The chemical energy comes from the food and the battery, while the nuclear energy comes from the nuclear reaction. Starting, and we will study here the three of the types of energy, and they are the potential energy, the kinetic energy, and the mechanical energy. Starting with the potential energy. Potential energy is the energy stored in the object due to its position. Again, the potential energy, it's the energy stored in the object due to its position. And from this, let's remember the weight. The weight equal mass multiply the acceleration of gravity, and from it we can get the potential energy. Potential energy equal weight multiply the height. Again, the potential energy equal weight multiply the height. The potential energy measured in joule, the weight measured in Newton, the height measured in meter. Again, so if you have the meter in centimeter or kilometer, we should convert it. From this law, we can conclude the factors affecting the potential energy. First, the weight. The weight and the potential energy, between them there is a direct relation or directly proportional, means when the weight increase, the potential energy increase. Also the height, also it's directly proportional with the potential energy. When the height increase, the potential energy increase. From this, if the weight is doubled, potential energy doubled. If the weight is reduced to half, the potential energy decrease to half. If the height increase to double, the potential energy increase to double. If the height reduced to half, the potential energy decreases to half. Let's see this example here. An object whose mass is 2.5 kilogram and it's at a height of 4 meters. Calculate its potential energy. If the height decreases by 1 meter, then calculate it, the new potential energy. First, the weight. I don't have the weight, so we should calculate it. The weight equal mass multiply the acceleration of gravity equal 2.5 multiply 10 equal 25 Newton. The potential energy at 4 meter height equal the weight multiply the height equals 25 multiply 4 equal 100 joule. This is the potential energy at 4 meter height. When the height decreases by 1 meter, the new height will be 3 meters. So the potential energy, the new potential energy equal 25 multiply 3 equal 75 joules. That's easy, right? Let's see the second example. If I have an object whose mass is 2 kilograms and it is at a height of 5 meters from the Earth's surface, calculate the potential energy. This is the first one. The second, potential energy when first the weight increases to double, the height is constant, the height from the Earth's surface decreases to half, the weight is constant, the weight increases to double, and the height decreases to half. Starting with the first, the potential energy. The potential energy again equal weight multiply height. I don't have the weight, so I should calculate the weight. Weight equal mass multiply gravity. It's equal 2 multiply 10 equal 20 Newton. Don't ever forget writing the measuring unit. From this, the potential energy equal weight multiply height, so it's equal 20 multiply 5. 20 multiply 5 equal 100 joule. This is the first. The second, that potential energy when weight increases to double, the height is constant. Weight increases to double, weight equal 20. So when weight increase to double means the weight here equal 40. 20 multiply 2 equal 40. So the potential energy equal 40 multiply 5 equal 200 joules. This means that the potential energy of an object increases to double when the weight increases to double. Means the potential energy of an object is directly proportional to its weight. The potential energy, the second here, its height from the Earth's surface decreased to half while the weight is constant. The height decreased to half, so 5 multiply 0.5 or half equal 2.5 meters. The potential energy equal the weight 20 multiply 2.5 equal 50 joules. This means that the potential energy of an object decreases to half when the height decreases to half. Means also the potential energy is directly proportional to the height. The last one here, the potential energy if the weight increases to double and the height decreases to half. Concentrate at this. When the weight increase to double, mean the weight equal 20 multiply 2 equal 40 Newton. The height decreases to half multiply 5 equal 2.5 meter. So the potential energy here equal 40 multiply 2.5 equal 100 joule. So the potential energy of the object is still constant. By increasing the weight to double and decreasing the height to half, the potential energy is constant. So that's it for today. Thank you for watching, and if you need anything you can reach us by logging into any of the social media accounts by scanning the QR code that you find in the end of this video, or you can contact to me directly to my WhatsApp by scanning the QR code and contact with me directly. And don't forget to share this video with your friends if you like it, and subscribe the YouTube channel. Thank you for watching. See you next time, and goodbye.